Hi, my name is Dane Myers from Team 6210X.
And I'm Lauren Myers, and I'm also from 6210X. We're both on a high school team, as we said, 6210X right now. But we have plenty of experience with ModKit programming, and VEX code is similar to ModKit. So we have a program already set up here, and Dane can explain what's already set up.
Currently, what we have here is a starting of a sort of state system for controlling the lift motor and the claw motor. We also have some controller setups that work with the lift states, and we also have a gyro, a script that prints the gyro to the brain.
All right, so then we also have what's already set up in the robot. We're using 6210 D's robot. They're a middle school team right now for at our school, and
Elementary team.
yeah, and we have a their devices set. We have a controller in here, but this will not be using the controller since it's just autonomous. A lift, a claw, left and right drive, and then the most important thing that you can set up any of your robots in here. The most important thing we want you to have is a gyro because we're talking about how to program gyro autonomous. Okay. So we have all the ports set up and everything in VEX code, and we're going to show you how to create um, a gyro program.
So first we're going to start off by downloading what we have here to the robot. We're going to be showing how the gyro works and how it displays its values.
So for autonomous gyro driving, to make this work, you need it to be able to the gyro values to be a little bit positive this way, and then that way make it a little bit negative, and then use math to always correct the how far the motors are turning to get the gyro value back to 0. But the problem we currently have with the gyro is, as you can see, it increases positively when you turn left, but as you go right, once you pass 0, it loops back around to 360, which is bad because we need it to go to those negative values. So how we're going to do that is use some math to adjust for that and make them into negative numbers.
And we can start by creating our code inside of the control frame. So we have a when started. What we want to do at the beginning of it was we wanted to start spinning the motors. So we're going to spin both of the drive motors. That is going to be the start of our program.
Yeah, so you want to have that because when you're autonomous programming, the easiest way to do this is to always have the program telling the motors to spin forward, and then using programming adjust the speed of that. So make it 0 if you want it to stop, and obviously adjust the speed according to um, that. And instead of spinning it forward and backward and forward and backward, you just adjust the velocity to negative or 0 and stuff like that.
So on these two is where we're going to be setting the velocity with some math here and variables. But first, let's get to the point where we need to figure out how to get these numbers negative instead of large. So we can do this with an if-else. Put an if-else up here.
Put the bottom in the corner.
There. All right. We start with the go to this gyro heading in degrees is greater than if the gyro in degrees is greater than 270, we set the gyro. We have some variables in here already. Set the gyro rotation. We'll also need another one for down here. Set the gyro rotation.
So we've already created some variables, but basically how you make a variable is obviously you just make a variable and then you name it. And so specifically we have gyro rotation is the numbers we're using the gyro heading that the sensor gives us and then creating a new variable that gives us those numbers that we want, meaning positive when it goes left and negative when it goes right. So then what he's doing here is basically saying if the heading those gyro numbers that it's giving us is greater than 270, so that means we didn't want to do greater than 180 because then in a run you couldn't turn the robot all the way around to 180 before then. So for example, with the robot, when you pull it down here. When you turn the robot 180, if we have the program set that it's greater than 180, then once it gets all the way around to here, it would then become negative. And then that's hard math to deal with later in the autonomous programming to deal with the negative numbers happening over here. So we don't want it to be able to set it to negative unless it goes all the way around, which you don't have to do as much. And this way, basically what it's saying is when the gyro is greater than 270, so once the gyro becomes 360 like it is here, it then sets the gyro heading to
the current gyro.
Yeah, the gyro rotation, the variable that we're using, to from the current gyro heading minus 360. So, for example, if it's right now, it's at 350, and then minus 360 would make it negative 10. So that's exactly what we want because this is 0, and so then that means that's negative 10 and that's positive 10. And then otherwise, it just sets it at the normal positive number.
Alright, so now we're going to start getting the math in here for the drive. So we're going to start with some with minus and a plus in the minus in the left and a plus in the right. This is going to be what we use to like get our turn, like it be able to turn back on track. So now we're going to want a multiplier. This is used to sort of like as a proportionality to the gyro.
Yeah, so what he's doing here is, as you can see, it says forever. So all this is running all the time. It's in an autonomous program. It's always setting this. So then that drive speed is in an autonomous program. You can set as you're going through. You want say in the middle of an autonomous program, you want it to go forward one like at 100 speed. You set that variable that you created as 100, and then you set a drive heading as the degrees you want it to go toward. So if you want it to go at 0, it always stay at 0. This makes it so that it will keep it at 0. So how Dane can explain how it works.
So what it does is you set your drive speed and your drive heading. So let's say you want to go forward at like 100 speed, and you want it to go at the 0 heading. So what you do is you set the drive speed to 100 and your drive heading to 0. So like what the math will do is drive speed 100 minus 0 minus, let's say the gyro rotation doesn't move and it stays at 0, and 0 times 0.7 is 0. So then it'll drive at 100 and 100. Let's say it hits something during that drive and it veers off course maybe like 20 degrees positive. So then what it'll do is it'll have this 0 minus 20 and this 0 minus 20. It'll add the proportionals, and so that'll be about like 14. This number will be 14. So then it'll have 100 minus 14 and 100 plus 14. And what this will do is it'll have the robot then correct itself by subtracting some from the left drive. Therefore, it'll make it so that it just keeps going back on an even 0 plane.
So it's constantly trying to change the speed of the left and right drive to turn back onto the course that it wants to be on. So we can demonstrate that by just creating a quick autonomous programming, and this is how you can use this in an actual autonomous programming.
Use the variable when like button press, because we have.
Yeah. Oh yeah. When the brain check is pressed, then you can set those variables. So set the drive speed.
So like this drive speed, if this was 100, it wouldn't be able to veer back if
Yeah,
this was
yeah.
a number. So
Okay,
you want it
so
to be like 80 or something like that.
yeah, so you always want it to be at 80 because then it can add to it and such. So then we want to set the drive heading to we can just have it go straight, so to 0. And then you can wait a couple seconds. Yeah.
Wait, just like 1 second.
Yep.
And set.
And then set and then you can set it to you can set the drive speed to 0. And then let's show it turning. So you can
you can just
let's wait 1 second.
It's control.
Yeah, sorry. Wait 1 second, and then you set drive speed again.
No, actually, you don't even have to set drive speed. You can just
set. Well, you need drive speed to go to turn to turn.
It actually still works on drive speed 0.
Yeah. Okay. Drive heading
to like 90.
to. Yep. So it'll turn 90 degrees. All right.
All right. So let's download this.
Yep.
All right. We're downloading.
Okay. So it's downloaded now. So what it should do is when we press the check mark, it should go forward a little bit and then turn. Yep.
Right,
and so as you can see, it turned and as you can see that it slowed down at that end of the turn because of that the fact that the goal minus actual is getting smaller as the difference between the goal and the actual is becoming smaller. That means that the drive speed becomes closer to 0 since we have the drive speed at 0. And that means that it slows down so that it can't overturn that 90 degrees. So we can show even it working in the drive.
As you can see, it actually once we turn it back.
Since it's always at drive speed, it's still wanting to go to 90.
It really badly wants to go to 90.
Yeah.
So now we're going to do another example of why and how the driving straight is affected by the gyro and how that can be helpful. So we're going to do another. We'll just move this down and change a couple of these numbers. So we're going to start with the drive speed. Because we have limited room on this table, we're going to make this a very small number, like 30.
Yeah.
We're going to then do that for, say, like 5 seconds. So we want to get a decent long amount of time driving. And then we're going to set it to 0, because we don't want it to drive infinitely. Alright.
So you can see that he doesn't have it in there, but drive heading is set to 0 at the beginning. So
all variables I'll just put it in there.
Yeah, just put it in there.
All variables default to 0 at the beginning of the program.
Yep. All right, so download that.
I'm gonna run it. All right. So now when
we press check, and as you can see, it's always wanting to go back to 0. No matter what.
No matter how hard we
turn it,
it will always want
to go back to that 0 spot.
Yeah.
So like, even if we, as you can see, it's still trying to go back to that 0 spot. But let's restart it and. it will continue to try to go back to that 0 spot in that straight run, which is super important because field variability, as one side of the field could be maybe more sloped, and then if you just had a just straight timed run, it would veer off to one side. But with this gyro, it can tell that it's veering off and straighten itself back up to the heading you want it to go at.
Yeah, and especially with all the little, tiny little nubs on the field, it is very helpful to that. Just in case like one of your wheels gets stuck on one of those, and you don't veer off to one side.
That was our lesson on how to do a gyro, and so next you can try out a field autonomous run with this.